All right, let's take a look at exam three. So this first question, first thing we're asked for is a probability distribution. So we have a bag that has 10 marbles in it, three red, two green, five blue. We're going to draw three marbles basically without replacement. We're going to let the random variable x stand for the number of blue marbles that I draw when I do this. So what are the possible values of that variable x? I believe we have four values. I can either draw no blue marbles or one or two or three. So we have to find the probability of all four of those happening. So let's say that x equals 0. So basically what I have to do is I have to draw three times and basically miss blue marbles every time. So how many non-blue marbles are there? There are five. So basically with my first draw, I have a 5 in 10 chance of drawing a non-blue marble. But then I want to do it again. So there are 9 marbles left, but only 4 non-blue. But then I want to do it out a third time. So there are 8 marbles left, only 3 non-blue. So this is my probability of drawing 3 non-blue marbles. So 20 times 3 is 60 over 720. And for now, I'll leave these all unreduced, and I'll reduce them later if it looks like it's going to be convenient to do so. So that's if I draw no blue marbles, that is the probability there. What about if I draw one? This is going to be a little more complicated because I don't care which marble I draw. Like, I don't care which marble is blue. So let's think about this. Let's say the first one is blue. What are the odds, or what's the probability that I draw a blue marble first? Well, there are 5 blue marbles, so that probability is going to be 5 out of 10. Okay, so I drew a blue marble. Now I want to draw a not blue marble. How many of those are there? There are 5. But how many marbles are left? There's 9 left. Okay, third, I want to draw a non-blue marble again, but there are 8 left. So again, I think my denominator is going to be 720. 5 times 5 is 25 times 4 is 100. So is my probability for drawing one blue marble really 100 out of 720? I think it's going to be higher because really this probability that I just calculated is if I draw a blue marble first, when really I could have drawn it first, second, or third. So because of that, I have to think about the number of combinations. Basically, I have to multiply this probability calculation by free choose 1. So it's not really 100 over 720, it's 300 over 720. All right, so moving on to x equals 2. And this calculation is going to look kind of familiar. So I'm going to kind of follow the same logic. I'm going to leave the combinations part until the end, but let's say that really it doesn't matter where my blue marbles are. I want there to be 2, but for starters, let's just say that the first 2 are going to be blue. There are 5 blue marbles, so I have a 5 out of 10 probability of picking that first. There are 4 blue marbles left out of 9. Okay, but for the third marble, I want to pick a non-blue. There are 5 of those of the remaining 8 marbles. But I have to think about the 3 choose 2 combinations that I could have done to basically put those marbles in those positions. That again is going to be 300 over 720. And just to kind of show the symmetry here, I didn't do this combination step here, but I could have. Really, this is a 3, choose 0, because of the 3 marbles I was choosing, I was trying to put a blue marble in none of those places. There's only one way to do that. So really, I'm multiplying this by 1, which doesn't alter my calculation at all. So finally, when x equals 3, let's just kind of follow the pattern here. Now I want all my marbles to be blue, which means, okay, that'll be 5 out of 10, then 4 out of 9, then 3 out of 8. I mean, that's identical to the calculation I did first. So that'll be 60 out of 720. Okay, so now, before I reduce, let's make sure this makes sense. Do these all add up to 720? 300 plus 300 is 600. 60 plus 60 is 120. 600 plus 120 is 720. So that's a good little like benchmark to show that all your probabilities add up to 1. So that, that never guarantees you're right, but at least it should make you feel like you're on the right track. So let's reduce these now. I think all these are divisible by 6. So this is going to be probability of 1/12. This will be 5/12, also 5/12, and then 1/12. So this is our probability model for this experiment. All right. And then from there, I can answer part B. What's the probability that x is at least 1? So x is greater than or equal to 1. Well, the probability there, that becomes a lot simpler to answer once I have a probability model. Basically, it's from there I can add up basically the cases where x equals 1, x equals 2, x equals 3. So 5/12 plus 5/12 plus 1/12. So that's equal to 11 over 12. And then finally, what's the expected value of x? So this is where that weighted probability or that weighted average comes from. So that the sum of all the x's times the probability of x. So 0 times the probability that x equals 0 plus 1 times the probability that x equals 1 plus 2 times the probability that x equals 2 plus 3 times the probability that x equals 3. So 0 times 1/12 plus 1 times 5/12 plus 2 times 5/12 plus 3 times 1/12. So what happens there? So I got, first one goes away. 5/12 plus 10/12 plus 3/12. So 5 plus 10 plus 3, that's 18/12, right? 18 over 12, that is 3 over 2. So basically, if I were to do this experiment, I would expect to come up with, again, your expected value it's an average. It's not always a value that's actually possible. If I were to do this draw 3 experiment several times, I would expect the average to be 1.5. All right, that's all for question 1. Question 2. All right, so I have a normal distribution question here. So I am going to pull up Desmos to kind of go along with this. All right, so I think we can do all of this with this normal dist function, which, or if you have a TI calculator, you can use that too, but I think this is pretty effective too. So we can assume that the heights of men and women in the US are normally distributed. So I'm going to set up two normal distributions here. So men's heights have a mean of 70 inches and a standard deviation of 3 inches. So I'll set up one normal distribution there and another for women, normal distribution. And that is 63.5 inches for the mean and 2.5 inches for the standard deviation. All right, so now we can answer these questions. So A, what is the probability that an American man chosen at random is shorter than 66 inches tall? So 66 inches is below the mean. So we should expect that number to be less than 50%. But let's set the max to 66 and see what we come up with. So we're getting a probability there of 0.091. So that's coming directly from our normal distribution, 0.091. B, what is the probability that if 6 American women are chosen at random, exactly 2 of them are taller than 67 inches? So part of this is simple, but there's a lot more kind of embellished onto this. So let's figure out part of this. What's the probability that one American woman chosen at random is taller than 67 inches? So minimum height, 67 inches. That probability is approximately 8%. So the rest of this we can kind of treat as a Bernoulli trial, kind of like a binary trial. So that probability is going to be, so basically we're going to choose 6 American women at random, and I want exactly 2 of them to be taller than 67 inches. So that'll be a combination where I'm going to choose 6 women, and I want to basically, of 6 women, I want to choose 2 of them, and I want basically there to be 2 successes. What's the rate of success? The rate of success is going to be 0.0808. And I want to raise that to the power of 2. But I also want to fail 4 times. So what's the fail rate? 1 minus, can I copy this number? Nope. Guess we're rounding it. Okay. But I also want 4 fails, so 0.9192. And I want to raise that to the 4th. So basically that's the calculation I'm going to make here. So I believe is it NCR? Yeah, NCR times 0.0808 raised to the power of 2 times 0.9192 raised to the power of 4. All right. So my percentage there, or my probability there, is approximately 0.0699. All right. And then for part C, the men and women who are in the top 1% of height are eligible to apply for financial aid from the Taller Scholar Foundation. So basically, I want to find the minimum height for people who are in the top 1%. So I'm going to take off these maximum heights. I'm also going to remove these. I don't need these anymore. So basically, I'm now trying to find the top 1%. I'm trying to find that bottom threshold, the minimum threshold for the top 1%. So let's just guess. I know that the mean is 70 inches. Let's try 75. Not high enough. 77 is too high. So let's try 76. So I think it's gonna be somewhere between 76 and 77. 76.5, 0.6, 0.7, 0.8, 0.9. I'm going to say 76.9 because I know 77 was too restrictive. Let's actually find it for women as well before I start writing things down. So let's go above the mean. How about 70? 70 is too restrictive. 68, not restrictive enough. 69, need to be a little more restrictive. 0.1, 0.2, 0.3, 0.4. So, and you may have gotten a little more accurate, a few more decimal places, but this is okay with me. So for men, what I found is 76.9 inches. So what is that? About 6.4, 6 foot, 4.9 inches. And for women, 69.3 inches. So that's 5 foot 9.3. All right, so that is all for question 2. So I think we're done with Desmos, but I'll leave it open just in case. All right, moving on to question 3. All right. All right, so we have a function, a multivariable function. So basically we want to find the critical points and then classify them. So how do we find the critical points for a function of more than one independent variable? We want to use partial derivatives. So I'm going to do that first. So partial f with respect to x, the 4 vanishes. X cubed, that derivative is 3x squared. For 3xy, the derivative of x is 1. The 3y, that's a constant multiple. So what's left is negative 3y. All right, so how about with partial of y with respect to, nope, not what I meant. Partial f with respect to y. 4 vanishes again. Y cubed, that derivative is 3y squared. And then 3xy, the y is the variable this time, so that y, the derivative of y is 1. The 3x is a constant, so now what I have there is 3x. So now that I have both those partial derivatives, I'm going to set them equal to 0. And what do I have here? I have 3x squared equals 3y. And 3y squared equals 3x. I can also get from those that x squared equals y. And y squared equals x. Okay. So a couple ways I can go with this, and they both are going to kind of get me to the same place. I'm going to take this top equation and square everything. If I do that, that gives me x to the 4th equals y squared. From there, I think I can plug this in for this bottom equation. That gives me this. X to the 4th equals x. So now essentially what I have is I have an equation that only has x in it. So I should be able to solve here. So to do that, I'm going to get everything on one side. X to the 4th minus x equals 0. And I can factor an x out. So x times x to the 3rd minus 1 equals 0. So now I have two factors equal to each other. That equals 0. The only way that that can happen is if one of the factors equals 0. So basically I can split these equations apart. So one of those is really simple. I just get x equals 0 more or less for free. The other one is x cubed minus 1 equals 0. From there I get that x cubed equals 1. Or that x equals 1. All right, so I even said here, find both of the critical points. So I got two values for x. So from those, I should be able to find the values of y that go with them. Because I know that x equals y squared. So when x equals 0, oh, I also have the y equals x squared. That'll be even easier. When x equals 0, y equals 0 squared. So that means y equals 0. So one of my critical points is 0, 0. When x equals 1, y equals x squared, which is 1 squared, which is 1. The other critical point is 1, 1. So those are my critical points. So that's part A. I found both the critical points. Part B is to classify them. So that's what I'm going to do now. I'm going to give myself a fresh slide to do that. So part A, my answers were 0, 0, and 1, 1. So how do we classify them? The way we classify critical points is through second derivatives. So let's quickly write down again what the partials were. The first order partials. This was 3x squared minus 3y. This was 3y squared minus 3x. So to figure out how to classify these, we need to get the second order partials. So the second order, like the unmixed ones, take the partial. So take this partial with respect to x again. That'll be 6x. Take the other unmixed partial with respect to y. That'll be 6y. And then take mixed ones. Fx with respect to y, that'll be -3. And then Fy with respect to x should be exactly the same as, basically the mixed ones should be exactly the same. And they are. So now we're going to do this. For 0, 0, we're going to evaluate the value of d. So d equals basically fxx times fyy minus fxy squared. So fxx, so 6 times 0, because now we're plugging in the values of x, times fyy, so 6 times 0 again, minus -3 squared. So what does that come out to be? That comes out to be -9. So when d is negative, what does that tell you? That tells you we have a saddle point. At 0, 0. So that's one thing we know. All right, now we have to do the same test for the 0.11. So now our x values and our x and y values are both 1. So 6 times 1 times 6 times 1 minus, and then these other partials are not dependent on x and y, they're just -3. So I get 6 times 6, 36 minus 9, that equals 27. So let's make this clear. Don't really care what the numbers are. I care about if they're positive or negative. I care about their signs. So I have a positive number here for D. What's also important is that fxx, it was equal to 6, which is also positive. So this is positive and D is positive. That means we have a relative minimum at 1, 1. All right, so we've found both critical points and figured out what kind of critical points they were. All right, moving on to question 4. So now we have a constrained optimization question. So we have a profit function below here. This is Z. And we also have a budgetary constraint. So what do X and Y stand for? X is the number of discs this company sells every month, and Y is basically advertising units. Okay. So how do we optimize something under a constraint? We have to use this Lagrange process. So we're going to take the function we're trying to optimize and take partials with respect to every independent variable there is. In this case, there are only 2. So partial with respect to x, 48x, that becomes 48. 96y, that's a constant with respect to x, so it vanishes. Negative x squared, it becomes minus 2x. Minus 2xy, it becomes minus 2y. Minus 9y squared, that vanishes. Okay, so partial with respect to y, what happens there? I get 96. The x squared vanishes. I get minus 2x again. And then the negative 9y squared, it becomes negative 18y. So those are my partials for f. The other thing I have to worry about is my constraint. So I'll call that g of x and y. That's equal to 20x plus 4y equals 216. I can also take those partials. So the partial with g with respect to x is going to be 20, because everything else in there is either with respect to y or truly constant. And then g, the partial of g with respect to y is 4. Okay. So basically what I'm going to do now here is I want to stack these partials up, so both in the x directions and the y directions. And basically I want them to be parallel to each other. And what that means is I want them to be whatever multiple f is of g, whatever multiple f is of g in the x direction, I want them to have that same multiple in the y direction. So that's where that lambda comes in. So I want 48 minus 2x minus 2y to be equal to 20 times lambda. And I want 96 minus 2x minus 18y to be equal to 4 times lambda. So now basically what I have is, through this Lagrange process, I have a system of equations that has how many unknowns? X, y, and lambda. It has 3 unknowns, which means it needs a third equation. That third equation is going to come directly from the constraint. Because the thing I'm trying to optimize is not an equation. It's a function, but I don't know what it's equal to. Whereas the constraint, 20x plus 4y equals 216, that has a level to it. That's a level curve. So that is my third equation. So now I have a good system. But really, I don't really care what the value of lambda is. It's kind of a means to an end. We usually don't find out what the value of it is. We usually just use it to kind of solve the system. So here's what I'm going to do. I'm going to use the lambda to kind of put the top 2 equations together. This top left expression equals 20 lambda. This middle expression equals 4 lambda. I'm going to multiply this middle left expression by 5. Basically, I'm going to multiply the whole middle expression or the middle equation by 5. So what will that give me? That'll give me that 96 times 5 is what? So 90 times 5 is, I'll just figure it out. So 480 minus 10x minus 90y equals 20 lambda. But what else equals 20 lambda? I also have 48 minus 2x minus 2y equals 20 lambda. So basically, since both those things equal 20 lambda, I can set them equal to each other. So 480 minus 10x minus 90y equals 48 minus 2x minus 2y. So now let's start putting things together. And in fact, while we're thinking about that, let's put all the variables on one side, all the constants on the other. So just to like 20x plus 4y equals 216. So if I move the 10x over, that'll be 8x plus 88y. 8x plus 88y. And then 480 minus 48 is 432. So my system of three equations is now a system of two equations and two unknowns. So 8x plus 88y equals 432. 20x plus 4y equals 216. All right. So solving the system of two equations and two unknowns is, relatively speaking, a lot simpler than solving a system of three equations, three unknowns. I think everything here is divisible by 4. That's 2x. I think this top one is divisible by 8. So x plus 11y. That's 432 divided by 8. 54. X plus 11y equals 54. How about this bottom one? 5x plus y equals 216 divided by 4. Also 54. Let's do elimination here. Let me multiply the top equation by 5, and then we'll subtract downward. So now I'm kind of working in a kind of a weird pattern, but that's okay. So minus 5x minus 55y equals minus 270. And then I'll just keep the other equation as is. 5x plus y equals 54. Is that okay? No. No. What are you doing? Multiply everything by 5, right? So why didn't I do that with 54? That's 270. I didn't write down a 0. 270. Okay, so now that I have that, I can add straight down. These are eliminating each other out. So negative 54y equals all right, so from there, I get a value of y equals 4. All right, so I got one of my unknowns. When y equals 4, what does that give me for x? X equals, if y equals 4, that means that 5x equals 50. That means that x equals 10. So these are the conditions that maximize the profit for this situation. So now, let's get a fresh slide to do our last bit of work here. So for A, the conditions that maximize our profit are x equals 10, y equals 4. So what is the maximum profit? We can find that by plugging in those values. What is f of 10 and 4? That'll be 48 times 10 plus 96 times 4 minus 10 squared minus 2 times 10 times 4 minus 9 times 4 squared. It's 480. All right, we got a final maximum profit of $540. All right, and that is all for question 4, and that's all for exam number 3.